Hello guys, today we are going to talk about adding UIKit dynamics to collection views, and I will walk you through the code that I have written to demonstrate how to use dynamic behavior together with collection views. But first I'm going to go over several links that I found in Google that were great help to me when I was developing this demonstration, because even though there is a documentation about dynamic animators, dynamic behaviors that those animators work with, there is not much there's not much documentation provided by Apple about how to use these dynamic animators and attachment behaviors with collection views. So for example, if you want to have a similar effect to a messages app, when the messages when you scroll the messages, you see that they behave with certain dynamics. So they're like spring. There's spring animations there. There's no such thing that you can find in Apple documentation, but fortunately there are different tutorials on the web, and you can look at those to actually get a grasp of how to work with UIKit dynamics. One of the first tutorials that I was looking at and I was trying to follow, because it's written in 2013 and it's in Objective-C. So this was a tutorial by Ash Furrow on Objective-C.io. And here in this tutorial he shows how to create a dynamic animator and add this animator to collection view, flow layout, and actually change the behavior of items when you scroll. So when you scroll the collection view. So this is all good, but it's still in Objective-C, and the first time I wanted to just port this to Swift, I actually failed because this thing didn't work, and I had to experiment myself with dynamic animation, with animator and attachment behaviors until I got it right. So basically, this tutorial is based on the work from the TNLAX tutorial with the Spring demo, which you can find on GitHub. So this is kind of an effect that we want to get, or maybe something better. So another thing that you can go and see how to work with UIKit dynamics, there is a great list, several tutorials on Ray Wenderlich, and there you can find information about working with animations, working with dynamic behaviors like gravity, collision, so on and so forth, with just playing with the views. Another one is a tutorial about tossing the views in Swift. This is just showing how to use the snap behavior as far as I see from the demonstration. And there is actually a good blog post about usage of dynamic item behavior in Swift by Ahmed Abdurrahman, and it's a two-part blog post where he discusses different issues with collision behaviors and how to optimize them and how to use them. So check it out, it's pretty interesting. So with this, I would like to start on the Swift approach to collection view and UIKit dynamics. And with this, I'm going to show you a demo of what's going on. Well, with this, I would like to start talking about how to implement UIKit dynamic behavior inside a collection view flow layout. So let's see. Here I have created an app, a small app for demonstration purposes. This app is basically, consists of a navigation controller with first initial catalog of several cells that lead to child screens. and each child screen is a collection view with different collection view layout. So if you look at this catalog controller, all that we have here is the UI table view controller that returns cells, and when you click on that cell, it executes a click handler. So for each that I've written for each cell, and whenever you click on the cell, we create a child view controller, set layout to it, set a number of columns, and push this view controller to a navigation controller. There are three types of controllers that I would like to show in this demo. First is without dynamics, which uses the standard collection view flow layout. Second is the layout with cells attached to their centers. So when you scroll, the cells they bounce up and down relative to their center, initial center position. This uses the class dynamic layout. And another one is showing how the cells connected to each other. So instead of cells pinned to their centers, they connected with springs to each other. So when you drag the cell, you see that your actual dragging movement that cells are under your finger, they follow your finger, and they create more natural springy motion. So this is described in connected layout, and this connected layout is just another take on the dynamic layout, but it's a little bit different than dynamic layout. Okay, so the effect that was discussed in Objective-C.io that I was started to replicate was this dynamic layout effect, where you have overall springy, bouncy motion. And we can look into this first. So in order to subclass a collection view layout, you have to implement or subclass different methods. With flow layout, number of methods that you have to implement is less than if you go with just overriding and creating your custom collection view layout from scratch. So with flow layout, subclass that we want to use, all we need to do is subclass the following methods. First of all, we will subclass prepare method. This method is called when the collection view layout invalidated, and it requests to recalculate the attributes of items that are on the screen. Then we will look into implementation of layout attributes for elements in rect. So this method is called when you you scroll the collection view, and collection view requests attributes for elements in a rect that is changed. Then the method layout attributes for item at index path is called sometimes by the collection view when, for example, it needs to insert or delete an item, or needs to request attributes of an item from an index path for some internal tasks. So we need to implement this method as well. And we are implementing the should invalidate for bounce change method that will be called on every bounce change. So while you're scrolling the collection view, this method will be called. And what we're going to do, the overall course of action is that all of our action is going to be inside should invalidate layout and inside prepare methods. So prepare method is called in the beginning of a layout calculation cycle. So in this case, when new items are available or some items becoming hidden, so new items appear, some items disappear, we want to adjust our animated behavior. So we want to adjust for which items we need to calculate the collection view attributes. And when our bounds are changing, we also need to take all the items that are affected by this change of bounds and modify those items so that their attributes are affected by the scrolling of collection view. meaning if you scroll the collection view, then you are moving the items that are on the screen somehow, and this will give you a nice dynamic physical motion. So first, let's look into the prepare method. And prepare method is pretty simple. So what it does is it finds out which elements, which layout attributes are currently on screen. So which elements are currently on screen. So we take the visible rect, which is collection view's frame offsetted by collection view origin. And we ask our collection view flow layout implementation to actually give us the attributes for those elements. And with this visible attributes, we can find out which items became invisible, so which items disappeared, and we can remove those items from the dynamic animator that we created. So after we removed the behaviors for those items, we can look again in the visible attributes and see which items are added, so which items appeared, and add new behaviors to the items that became available for us. So when it comes to removing disappeared behaviors, what we're going to do is we're going to identify those items that became off-screen by index path. So the things here, the things may be a little bit ambiguous, because what we're going to do is we're going to work with behaviors provided by the animator. So here I have a helper method that returns all the behaviors inside of animator. So dynamic animator may have a lot of different behaviors that are valid for different dynamic items. And dynamic item is a protocol that is implemented by UI view and by UI collection view layout attributes. So when you're adding a behavior to dynamic animator, it will end up in the behaviors array. Since we will be adding and working within this layout, we will be working with only attachment behavior. In this helper method behaviors, I'm going to loop through the behaviors array and take only attachment behaviors. And each attachment behavior has a reference to a dynamic item. So meaning each attachment behavior has a reference to a collection view layout attribute that was passed to it during this behavior initialization. And that's why we can go through all the behaviors and filter them by the behaviors that have items that do not reside inside visible paths. In this case, we will find out all the behaviors that are connected to the disappeared items, and we call it disappeared behaviors. And for each such behavior, we remove it from animator during the prepare calculation. So after we removed disappeared behaviors, we need to add newly appeared behaviors with regards to the visible attributes that are already on the screen. So how to do this? So we know that inside of animators we have a set of behaviors, and from that behaviors we can get currently available collection view layout attributes. So what we do is we go through behaviors and we look at the attachment behaviors that has each attachment behavior that has collection view layout attribute available for us, and we get each such animated attribute and take its index path. In this case, we get all the behaviors that are present inside animator, all the index paths that are correlating to the behaviors present inside animator. And what we do then is we filter the visible attributes that we have. We filter out those that are existing already, and we are left with those that are not existing. So filter those that do not reside inside existing paths. And in this case, for each such behavior, we want to create a new attachment behavior. So for each such attribute, we need to create a new attachment behavior, adjust this behavior according to the current position, and add the behavior to the animator. So this is the prepare cycle, and before we look into update attribute method, we will look into it a little bit later. I want to show you how this behavior is created. So any behavior that I'm creating here is an attachment behavior that accepts an item, which is layout attribute, and attachment anchor, which is the center of this attribute. So you see, this thing provides us with a set of behaviors when we pin the items to their initial center positions, and that allows us to later to nudge those items, to move those items a little bit, so that their actual position will be different from their initial position, and that will create a force represented by this attachment behavior that will try to move the item back to its initial position, and that will create the physical motion. So in order to have this this behavior to be interesting, we can control its attributes such as damping, frequency, and length. So damping is how springy the motion of the item will be. The length is the distance from item center to the anchor. In this case, we would use 0 for this. Frequency is the frequency of oscillation, so how quick is going to be bouncing effect. In our case, we put it 1, so 1 bounce per second, which is looks like a pretty decent value. So when we created behavior, we need to adjust its attributes, and this is done inside this update attribute method. We'll go to it soon. And then we add this behavior to the animator. And by that time, we are done processing layout attributes that are visible when our calculation of the layout starts, every time our layout becomes invalidated. So this thing adjusts the behaviors and positions of the items that are going off the screen or going in the screen, so appearing or disappearing. But what about items that are already on the screen? So for those items, we need to go inside should invalidate behavior or should invalidate layout, and inside this method we will process all the items that are currently on the screen, and we adjust their centers so that the attachment behaviors will be activated, and they will force those items to go from the adjusted center position back to the initial center position. And here the core of this method is actually calling of the update attribute method that will take each behavior and work with item from this behavior. In order to work with in order to calculate the appropriate adjusted position, we need to get the translation. We need to get the difference between the new bounds that are provided when we're scrolling and the old bounds, the current bounds of the collection view. And with this notion of translation, this will help us to this will be actually the amount of vertical adjustments multiplied by some factor that will make this adjustment proportional to the distance between the item center and the location of the touch. So the bigger the distance from the touch will be, the less the bigger the distance from the touch will be, the bigger the adjustment of vertical position will be. So okay, let's look in this update attribute in detail. So here what we have is in input we get a behavior, attachment behavior, and from that behavior we can take behavior item as collection view layout attribute, since this is guaranteed because every attachment behavior is created with just one item, and we can take this item or attribute and update its center position. So in order to update its center position, what we're going to use is we're going to use the maximum or minimum of two values. Either it's going to be the translation that we calculated before, so the difference between bounds, old bounds and new bounds of the collection view, or the translation multiplied by factor. And in here, in this case, factor is depending on the distance from the touch location or from some screen anchor. So so in order to calculate our center position, we need to get the factor, and the factor we get from the screen anchor and the anchor point of the behavior. So screen anchor, what is it? Screen anchor is basically can be two things. One thing is it can be position of the touch of your finger on the screen, or it can be the center of the collection view bounds. Why is that? Why do I need two different values for the screen anchor? So you see, when you're scrolling the collection view programmatically using the set content offset or using scroll item to index path, in this case you don't have any touch location of the touch. So every location that will be returned from the pen gesture recognizer will be your old touch location, which can be completely unrelated to the current situation. In this case, if we change the bounds of the collection view programmatically, what we're gonna do is we're going to ignore the touch location and use the actual center of the collection view bounds. So in order to find out is the gesture recognizer is active or not, are we touching or not, we're going to ask for gesture recognizer state and see if it's in the state of changed or not. When we are going to touch, the gesture recognizer will be in the state changed, and in that case we can differentiate between the mode, are we touching or not, and we can select the appropriate screen anchor to calculate the factor, basically the multiplier for the translation. So with all this code, what it does is it takes the change in the bounds, multiplies it but by some number. In this case it's going to be a small number, since spring stiffness is 2000 here, and the distance between screen anchor and behavior anchor point is in a matter of hundreds. So on each screen invalidation, on each bounce invalidation, our addition to the center Y position will be small, but since we're going to since this method is going to be called many times during a scroll, all this will add up to the nice physics behavior. And I'm going to show you a demo of how does it look on an actual device. So let's see. So first, let's look how it looks without any dynamic behavior. When we scroll the collection view and we stop it or we move it like this, it's pretty static and it's rigid. So if we play with this, there's not much of interesting animations going on. So now let's compare this to the behavior where the cells attached to their centers, their initial centers. So you see there's a little bit wobbling already, but when we start doing the small movements, we see that all those items are exhibiting those springy motion. And we scroll and we stop things, and we can see that there is small motion of the items of the collection view.